Okay, today's aim is how do we find the missing side of a right triangle? So the question is, what formula do you use to find the lengths of a side of a right triangle? In other words, if you're given two sides of a triangle, how do you find the length of the third side? So if you remember with a right triangle, the relationship that exists between the two legs and the hypotenuse is as follows. Leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. In other words, the sum of the square of the two legs of the triangle is equal to the hypotenuse squared. You might remember this much better as a squared plus b squared is equal to c squared, where a and b are both legs of the triangle. We'll call this a, and whoops, that looks like a 9. Let's change that. Let's undo that. We'll call this leg A. We'll call this leg B. So a squared plus b squared is equal to c squared. Let's take a look at some examples. So they're saying use the formula to solve the missing side of each triangle. Let's give us some more space. So let's take the first one, A. So I have one leg that's 3, one leg that's 4. What is the length of the hypotenuse? So we're going to use a formula. A squared plus b squared is equal to c squared. So we're going to substitute a with 3, so I have 3 squared, plus we're going to substitute b with 4, that's 4 squared, is equal to c squared. We're going to substitute c with x. And what I'm asked to do is to solve for x in each one of these. Okay, so 3 squared is equal to 9, and 4 squared is equal to 16. So 9 plus 16 is equal to x squared. 9 plus 16 is 25, so 25 is equal to x squared. And because I want to solve for x, what I want to do is take the square root of both sides of my equation. So I'm going to take the square root of x squared because I want to solve for x, but which means that I'm going to have to take the square root of 25 as well. So the square root of x squared is x equals, and the square root of 25 is 5. So the answer is x is equal to 5. Let's take another example. Suppose I'm given a leg of a triangle and I'm asked to find the other leg when I'm also given the hypotenuse. So again, I'm going to use the formula a squared plus b squared is equal to c squared. I'm going to substitute a with 5, so I have 5 squared, plus I'm going to substitute b with x, so I have x squared, is equal to c squared. I'm going to substitute c with 13, so I have 13 squared. So 5 squared is 25, plus x squared is equal to 169, which is 13 squared. What I'm going to do is subtract 25 from both sides of the equation. So subtract 25 from the left side, subtract 25 from the right side. And what we're left with is x squared is equal to 144, because 169 minus 25 is 144. Once again, I've got to take the square root of both sides of my equation. So I'm going to take the square root of x squared, which means I'm going to have to take the square root of 144 as well. The square root of x squared is x, and the square root of 144 is 12. So mystery solved. The other leg of the triangle is 12. What I'd like you to do is try C and D on your own. Put your player on pause, and when you're done, hit play and compare your answers. Okay, so here's an example when once again I'm given one leg of a triangle, I'm given the hypotenuse, and I'm asked to find the length of the other leg. So I'm going to again use the formula, Pythagorean theorem, namely, whoops, that's not what I wanted to do. Let me undo that. Let's try this again. So I'm going to use the formula. Well, that's not what I wanted to do. Third time's a charm. Okay, should work. So I'm going to use a squared plus b squared is equal to c squared. I'm going to substitute a with x, so that's x squared, plus b, I'm going to substitute b with 15, that's 15 squared, is equal to 17 squared. Good. So I have x squared plus 225 is equal to 289. And if you subtract 225 from both sides of your equation, you're going to subtract 225 from the left side, we're going to subtract 225 from the right side, we get x squared is equal to 64, because 289 minus 225 is 64, not 69. Let's undo that. So x squared is equal to 64. There we go. So once again, I've got to solve for x, not x squared. So what I'm going to do is I'm going to take the square root of the left side of my equation, and I'm going to take the square root of the right side of my equation. The square root of x squared is x, and the square root of 64 is 8. So the answer is x equals 8. Let's take a look at this one. Now, you'll notice I have a leg that's 3 and a hypotenuse that's 4. Now, question D is very different than question A, because in question A, the leg was 3 and the other leg was 4. In this case, a leg is 3 and the hypotenuse is 4. So you might think, oh, this is a 3, 4, 5 triangle. This must also be a 3, 4, 5 triangle. Not so. You have to remember that in a right triangle, the hypotenuse is always longer than each of the other two legs. So this leg, which is now x, cannot possibly be 5, because that would make a leg larger than the hypotenuse, which makes no sense. So I'm going to set up my equation the same way. A squared plus b squared is equal to c squared. I'm going to substitute a with 3, that's 3 squared, plus I'm going to substitute b with x. X squared is equal to, I'm going to substitute c with 4, 4 squared. So 3 squared is 9, that's 9, plus x squared is equal to 16. Now I'm going to substitute 9, I'm going to subtract 9 from both sides, which means x squared is equal to 7. Once again, I've got to take the square root of both sides of my equation, because I'm solving for x. The square root of x squared is x, equals the square root of 7. And this, folks, is a perfectly fine answer. It is an irrational number, but that's perfectly fine. The length of this leg is the square root of 7. Let's try a different type of question. Suppose I'm asked to prove whether or not a given triangle is a right triangle. So let's take an example. Prove whether or not triangle ABC with the given side lengths is a right triangle. So the first thing I would do is draw myself a diagram. So let's draw a right triangle. There we go. And notice how AC is 15. That means AC has got to be my hypotenuse. So I'm going to put A over here. I'm going to put C over here. This is 15, right? And this has got to be B. And this will equal 9. AB is 9, and BC is 12. The question is 9, 12, 15 a right triangle or not? You know what I should do? I should actually erase this, because what I'm trying to find out is this a right triangle? I have no idea. So in order to test this out, I'm going to set up my Pythagorean theorem exactly the same way as I did before. So I'm going to, let's try this again. Oh, there we go. Okay. So a squared plus b squared is equal to c squared. So my question is 9, 12, 15 a right triangle? Let's substitute a with 9. Let's make that look like a 9. Let's substitute a with 9. Let's substitute b with 12. And let's substitute c with 15. And my question is this True. Is 9 squared plus 12 squared equal to 15 squared? That is the question. If it is, then my answer is yes, it is a right triangle. If the left side of my equation is not equal to the right side, then a 9, 12, 15 triangle could not possibly be a right triangle. Let's do the math. 9 squared is 81, plus 12 squared is 144, and 15 squared is 225. So the question is 81 plus 144 equal to 225? And the answer is yes, it is. 225 is equal to 225. So my answer is yes, it is a right triangle. Why? Because of that. There's my proof. Okay, so this is what I'd like you to do. Try these two questions, numbers 1 and 2. A triangle has sides 6, 7, and 10. Is it a right triangle? Justify your answer by proving it. Then I'd also like you to do question number 2A and B. Find the third side of each triangle. Leave your answer in simplest radical form. And then they also want you to round your answers to the nearest tenth. So why don't you try that by putting your player on pause and then coming back in 5 minutes. Okay, let's do the first one. Is a 6, 7, 10 triangle a right triangle? So we're going to draw ourselves a triangle. We're going to call this 6, we're going to call this 7, we're going to call this 10. And again, I'm going to apply the Pythagorean theorem, which says a squared plus b squared is equal to c squared. Let's substitute a with 6. Let's substitute b with 7. And let's substitute c with 10. And my question is this true? Let's see. 6 squared is 36, plus 7 squared is 49, and 10 squared, of course, is 100. 36 and 49. Let's see, 9 plus 6 is 15, carry the 1, 4 plus 4 is 8, and 85 is not equal to 100. So my answer is no. Why? Because of that. Okay, let's take a look at the other two questions. So, find the third side of each triangle below. So, 4, 8, and they're asking us to find the hypotenuse C. Okay, so again, I'm going to apply a squared plus b squared is equal to c squared. Let's substitute a with 4, so 4 squared, plus we're going to substitute b with 8, that's 8 squared, is equal to c squared. 4 squared is 16, plus a squared is 64, is equal to c squared. So c squared is equal to 16 plus 64, which is 80. So what I'm going to do is take the square root of both sides, and let's do that. Let's do this in red. So I'm going to take the square root of c squared. I'm going to take the square root of 80. So the square root of c squared is c. So c is equal to the square root of 80. But we don't like to leave the square root of 80 in that form. We want to simplify this radical. So in other words, I want to look for the largest perfect square that goes into 80. So let's see what that is. Well, 4 goes into 80 20 times, but 4 is not the largest perfect square that goes into 80. It turns out that 16 is the largest perfect square that goes into 80. So c is equal to the square root of 16 times 5. So I can express this as the square root of 16 times the square root of 5. The square root of 16 is 4, so my answer is 4 radical 5, and that is the value of c. Now, they're also asking us to leave your answers rounded to the nearest hundredth. So what we're going to do is grab our calculator, and let's take the square root of 80. So we're going to do 80, and we're going to take its square root and round it to the nearest number. The nearest, what did they say? They said round to the nearest hundredth. So if I round to the nearest hundredth, that means I have to look to the thousandth place. So that's 8.94. So my answer is 8.94. So this is my answer to C, and this is my answer to